Hello and welcome to today's topic, Introduction to Kubernetes Cloud Native Data Management. This is a hot topic for all of us in the IT organization as more and more companies are migrating to cloud native architectures. But there's a lot of confusion around virtual machines versus containers and what's needed really to run containers in production and keep your data protected. So this is going to be a great educational event. I'm confident that after this event, you'll get answers to all your questions around cloud native data management. Thank you so much to our friends at Veeam for joining us on the event today. Here in just a moment, I'll introduce you to today's expert presenter. But first, I should mention that my name is David Davis of Actual Tech Media, and I'll be serving as the moderator. We want this event to be educational. We encourage your questions, and we even have a Best Question prize to help further encourage those questions. We'll be taking your questions live at the end of the webinar today. We also have a number of resources there in the Handouts tab for additional information on Kubernetes and protecting your cloud-native application, so make sure that you check those out. And then at the end of the webinar, I'll announce the winner of our Amazon $300 gift card door prize. Of course, you must meet the Actual Tech Media prize terms and conditions that you'll find there in the Handouts tab. And then, as I mentioned, we also have our Best Question prize for an additional gift card, an Amazon $50 gift card. Prize winners will be selected and contacted after the event. And with that, I'm excited now to introduce you to today's expert presenter. Welcome, Mr. Michael Cade, Senior Technologist for Product Strategy at Kasten, which is a Veeam company. Michael, it's great to have you on. Take it away.
Yeah, hey everyone. So just a brief intro to me. So as David said, Michael Cade from Veeam. I've been at Veeam for well over 6 years, and I obviously focus around data management, and even more recently, over the last couple of years, but even more so the last 6 months, I've definitely been focused around cloud native, but more importantly around Kubernetes and our focus around Kasten, which is protecting workloads within Kubernetes. So I very much come from a virtual and infrastructure background. The session today is not so much an introduction into cloud native data management, and we're not going to get into product specifics until we get right to the end, where we'll talk about Kasten K10. But ultimately, we're going to get into the weeds about kind of my journey into learning about Kubernetes, cloud native, how we got here, and all of that good stuff. Because so I come from that virtualization admin background, as I'm sure many of you do as well, from in your day-to-day jobs as well. So from an agenda point of view, I want to touch on how we got here in terms of physical, virtual, cloud, and now containers and container orchestration. I want to touch on the very high level of the Kubernetes building blocks, as well as a bit of a Kasten K10 overview and how it's a little bit different to what we may be familiar with from a virtualization point of view, or physical, or even cloud. So let's jump straight into where we are, from how we got here. And before we kick off with that, I'm sure many of you have seen this rise or this exposure to DevOps, and DevOps being a focus around the developer and bringing development and operations closer together, so that it's no longer a Friday afternoon throw over the fence to the operations team to then have to juggle the application around to look after that, and any of the downtime, any of the updates then are on the operations team. DevOps enables us to incorporate automation, infrastructure as code, desired state configurations, and a lot more into that same workflow, but basically by bringing the two in together so that we're working much closer together. And that Kubernetes piece is one part or one platform that we definitely see as part of that DevOps toolkit. But also we're seeing this rise of the platform operator, where they have a first and foremost focus on the platform, whatever that may be, whether it be running Kubernetes or running vSphere or running the platform, wherever that needs to be, potentially up in the public cloud, a managed service example. But I've been calling it like a 70% split, and then a 30% split on like actual development. How does the development workflow look like? How do we release code into our workflow? Whereas from a DevOps point of view, we're definitely the other way. So 70% focused on the development, the CI/CD pipeline workflows, and etc., and then 30% on the platform. And then an SRE and the DevOps team are working together to ensure that we can release as fast as possible, but be as efficient as possible on the platform that we're on as well. So we're going to very much see a lot of this as we go through. Now, we know where we've come from and how we got here, but it's useful to kind of touch on, go way back. And this I definitely, the spoiler here is that none of this has gone away. We still have physical machines in our data center. Not everything has gone to containerization or cloud or public cloud. I'm sure that actually a large majority of us on the call still have their own data center. We're running virtualization. We're definitely probably still running an element of physical machine. But it's useful to just understand that history and how we got here. So we started off from a physical point of view, where obviously that would have an operating system on. It would leverage the CPU, the memory, the resources of the underpinning server. And we know then that we'd cram as many applications onto that one server, and we would be taking up real estate within our data center. Then along came virtualization, and it enabled us to abstract that hardware and allow us to be more efficient from that, but also shrink down that physical footprint within the data center on how we were leveraging that, which also meant that we could split out our applications in a way that we could have our different applications running on each individual virtual machine, potentially on the same physical hardware, but now segregated away and abstracted away. Then along came the cloud, whether that cloud IaaS model, so takes away that physical footprint completely and offloads that to someone else. You pay the money to someone else to manage that. And then even further down there, we've got our PaaS, so takes away the operating system, takes away the virtualization piece, and just gives you a database. And then you've got SaaS, which is ultimately going to give you the front end application that enables you to consume a service, Office 365, Salesforce, for example. No one using those tools has a clue on what the underpinning technology, the hardware looks like. You pay to abstract that layer of manageability and administration. Then along came containerization, and I'm not saying that these are relatively new enhancements. These have been things that have come over time. Containerization is no way near new, but it's about abstraction again, an abstraction of the operating system at this point, and it enables us to run applications on the same operating system, host node, to be able to be very tiny. Now, the one key difference between a virtual machine and a container, and we'll get into some of those, the differences, is that with a container, we're generally talking about megabytes of size, or meg in size, versus a gig in size virtual machine. So we have to carry the whole operating system when it comes to virtualization, whereas containers, we just take a little bit of the operating system. The container runtime just takes what it needs from the underlying operating system. And I think the key message that I want to portray here is that none of these have gone away. As we just said, physical systems, virtualization, cloud, containers, it's like vehicles. We've got many different types of vehicles, and we use the right one for the right job. And I've been using that analogy, and it seems to work quite well. And you wouldn't necessarily use a push bike to move house. I'd probably advise against it. But it's there. It's going to be a really good way of getting from A to B instead of using a car or instead of using a truck. But obviously, there's different analogies, and we can go into that a lot more. But I'll leave you with that, is that the safety option is none of these are going away. But the key part is well, the awareness of these platforms, so that you know that when you come up for tech refresh, it's not just, oh, the only option I've got is to continue where I am going. You've actually got choice, potentially an overwhelming choice, because there's a lot of education and other aspects that you have to think about, whether it's CapEx, whether it's OpEx. But ultimately, which one do you choose for the right job? Because ultimately, I can run a virtual machine running an application. I can run it on premises. I can run it in the cloud. Potentially, that software vendor has already containerized that. So there's a different option as to where you store that, and there'll be different driving factors for all of you as to when and where you leverage the technologies. But they can all live side by side. We can use and leverage everything accordingly. But also, it's going to come down to education, trust, and whether you're capable of being able to, or wanting to take that plunge. It's a bit like everyone can use the cloud, but if you're not comfortable, if you're not educated on what that needs to look like for a business, and you think the costs are going to spiral out of control, I strongly expect that you're probably not going to go and pile everything into the public cloud without that awareness. So I think it's also worth noting, and this goes down to something that I found as I was exploring this world, was around containers versus VMs. And if you go onto any search engine and you type in containers and VMs, literally that first page generally comes up with containers versus VMs. And they make it a and or definitely a versus by all accounts. And that shouldn't be the case at all, because a container is not the same as VMs. It's all going to depend on what your application, what your delivery model needs to look like within your business. Now, can you containerize everything you're doing? Yes. Do you have the skill set to do it? Maybe. But should you do it? Maybe. Like, there's all these questions that need to be answered. But generally speaking, they're completely different. It's a bit like a VM being compared to IaaS, or a VM being compared to a physical machine. Yeah, they're kind of the same. Or a van being compared to a truck. Like, they all go on the motorway. They all move. They can lift. They can take one person from A to B. But generally speaking, they serve different purposes overall. And that's kind of what I'm trying to dispel here, is that just because this is strange, considering I'm a technologist for containerization and Kubernetes, is that just make sure that you're using the technology, using the platform for the right reasons, not just because it's a buzzword out there, because it's not a buzzword. We know that hundreds of or thousands of companies are using Kubernetes in the right fashion, and not just for the sake of it, but be sure that you're making the right decision on what platform you're using. And just to jump into that containerization a little bit deeper, is that so containers alone can live standalone. You could absolutely run Docker, because everyone knows Docker. You can run Docker containers on a host, and you can serve a website or an application pretty easily at that point. Now, where it becomes very difficult is when you want to scale up, scale out, and scale down those deployments, those applications. That's where you need something like a container orchestration engine, namely Kubernetes. And if you think about the analogy I use here, or the similarity that I use here, is when we look at vSphere, and I'm massively generalizing if everyone is aware of virtualization and VMware vSphere, is that we could absolutely go and run a virtual machine on an ESXi host, and that's great. And we could probably get 20 to 30, maybe even more density of virtual machines on a single piece of hardware on serving our virtual machines. But if that host dies, all of those VMs also die. And then along comes Virtual Center, which allows you to pool or cluster all of your nodes together, which enables you to have a big resource pool of hardware or resources that allows you to move your VMs freely between, giving you high availability, giving you potential fault tolerance against failure of that, but also being able to load balance between that. And ultimately, that's really what Kubernetes does from a container point of view. It enables you to pool your resources together as a cluster so that you can serve data. And one of the things that I wanted to highlight on this page, just to start getting into the Kubernetes terminology, is that if we look at applications that have been split out, and what I mean by split out is that no longer in the microservices world or cloud native world will you have one monolithic application such as Exchange or a web server. They would be broken out into various different services, and each service or application would live within its own container, and you would then be able to scale out and up accordingly as to what service needs more attention. And what we do is we have the capability of being able to have something called a deployment, which brings all of those different small application parts together into a desired state. So a deployment is a desired state. And then if we think about our ESXi hosts or our virtual machines or our physical bare metal, we think of those as nodes. So that's where we're going to be running our containers, or in the Kubernetes world, that's where we're going to be running our pods. So there's a few benefits to obviously both. Virtualization enables you to run multiple operating systems on whatever physical server you want to host those on. And VMs are for the apps that need all the operating systems. So if you need something that has to have all of the binaries within the operating system, great. Virtualizations is the way to go. When you want to deploy multiple applications that tend to live together on one virtual machine, virtualization is the way to go. But when also you have a wide variety of different operating systems, you potentially want to look at virtualization because of that, the nature of being able to split out and manage multiple operating systems on any virtual machine. I think the other key area there is that your VMs are not beholden to the underpinning operating system, which when we get into containerization, it's very much, if there's a vulnerability on your node, then that vulnerability will also be a vulnerability to your container as well, and to your application. However, the benefits there around containerization is very much another abstraction layer, in that we're minimizing our footprint again, because we're now talking meg, but also being able to scale up, scale down. We can be very efficient on what those nodes actually look like within there. Also, from a pod point of view, and I'm pretty sure I can't see anyone out there in the audience, but from a virtualization point of view, we've all kept virtual machines for months, years, maybe decades. With a container or with a pod, they're generally going to be fast moving. You're going to be getting rid of those very quickly. Not getting rid, but you're going to be updating those. You're going to be changing what they look like. And versioning now becomes a potential daily thing, an hourly thing if need be, through those CI/CD pipelines. But I don't want to get into too much of that terminology. But hopefully that's useful in terms of like a high level how we got here. I know we're going to go to a poll now, David. If you're
That's
in.
right. Yeah, we've got a poll on the screen that says, are you using or planning to use containers in your environment today? And of course, the options here, maybe you're just doing a proof of concept, maybe you've got containers in development or testing, or maybe in production, or perhaps just still learning about containers and what they can do for you. So this is a cool topic. We got a lot of good questions coming in as well.
Cool. And I think, so I was going to say, David, kind of as expected, given the title of the session, that still learning is like high from a, but that's great, because that's kind of the nature of the session, is that we're literally at the surface of the water. We're not going to go deep into anything. I don't want to. It's already very daunting. I think everyone would agree. This whole topic can seem very daunting. I remember going, like, if we go back a few years to virtualization, in particular VMware, that whole ecosystem looked quite overwhelming. The learning curve looked steep. And I think we're in a similar situation here, but things are moving much faster, as they do in technology. And I think that still learning part is key to that awareness and just understanding that. So kind of expected to see that still learning to be the highest on there, but also good to see that there's some blue on the other areas as well.
Yeah, absolutely. It looks like, roughly half the audience is still learning, and 16% doing a proof of concept, 13% in production. So a good mix of container adoption out there, and also, a good mix of folks still learning about this topic.
Yeah, good stuff. Yeah, so hopefully, the running in production people can keep me honest, and everyone thereafter, they're still learning. Yeah, hopefully we can help you on that journey.
Excellent. So how do you orchestrate these containers, Michael?
Yeah, so that's the next part is to really, again, we're not going to go deep into it. I just want to touch on some of the terminology and concepts of Kubernetes. So let's we'll get into the building blocks, but before we do that, I think it's quite easy to say is that Kubernetes is that next wave of infrastructure. I've already touched on virtualization, physical, cloud, and already upon us. So public cloud, AWS, Azure, Google, managed services, they don't feel like they've been here that long at all. And we're already talking about this cloud native world. We're talking about Kubernetes. This is how fast things are moving. And I think to put it into a bit more detail, and I think I've very much kind of likened this to vSphere, or at least vSphere vCenter. So that management orchestration layer, it kind of fits that same story. Now, Kubernetes is a container orchestration engine. It's not the exclusive container orchestration engine as much as it is kind of very much winning, if not won that race around container orchestration. But I think it's also worth sharing that there are other container orchestration engines out there as well. So we have Mesos, we have Nomad, we have Docker Swarm, but still that Kubernetes wave is very much bigger, wider, and very much stronger than the others. But really what we look at from a container orchestration engine is very much that orchestration of our containers or our pods that we'll talk about in the building blocks of Kubernetes. And it's really there to make sure that our cluster is healthy. It's going to schedule all of our pods to be in the right place. If something doesn't look quite right, it's going to let us know. It's going to fix that. It's going to try and fix it at least. All of the things that we know that vCenter does today. It didn't do it from day one, but we've learned from that, and Kubernetes definitely has that capability of being able to heal or have health management around that. Okay, so kind of again, this is relaying what that looks like in a visual environment. So container orchestration manages the deployment, the placement, and the lifecycle of containers. But it also has many other responsibilities. We don't need to get into that too much today. But if we think about that orchestration layer, that is going to enable us to put our pods, and I'll get into pods shortly, into the right place. It's not going to overload one particular node. It's going to load balance them accordingly and allow us to orchestrate those pods and the deployment of those across our resources. So hopefully that helps clear up maybe some of that. What we will do is we'll go into a little bit more about what those nodes look like now. So a node, again, could be a bare metal server, could be a virtualization, could be a VM, could be a cloud-based offering where you're actually paying for those nodes to be managed for you, and you never have access to them. And generally speaking, is the same model that I mentioned before is we can always pay someone to look after it. And that's obviously fine if we want to take advantage up the stack and remove that. A lot of you will have moved to Office 365, to Salesforce, whereas before our CRM, our Exchange servers, etc., would have all lived on premises, and someone would have had to have spent the time caring for that virtual machine. So very much an agnostic approach to where this lives, whether it's virtual machine, whether it's physical, but also the architecture of that. And this is the beauty of Kubernetes in itself, is that Kubernetes can really live anywhere. And that lends itself very nicely to that application portability, about being able to move workloads from one specific cloud provider to another. And this is where I'm starting to get into talking about data management, how we can help from that from a Kasten point of view. But also on those nodes, we have two important aspects to it. There's a bit more, but the two key areas is one, the kubelet. And the kubelet is there to speak to the API server. So any instruction that comes in to the control plane tells the kubelet what's going on your node. And each node has a kubelet, and it's basically that phone home type action. And then we also have the kube proxy, so that's how each of the nodes speak to each other in the cluster as well. And if we start to put that together from an architecture point of view, we have our worker nodes, which is where our pods, our workloads are going to live. And then within the same cluster, we have something called a master, or more recently, it's been renamed to a control plane. And that control plane gives us it's completely the brains of the operation. No workloads live on there generally, apart from management and administration. Now, that control plane can be also made highly available and all of that good stuff. And those worker nodes can be scaled out accordingly. You can have a 1-node cluster, 2-node, 3-node, 100-node. And we actually have customers that are using 100-node clusters, but we also have clusters that have got many customers that have many 10-node clusters, for example, to split out different workloads, test, dev type environments. But the key part is that every node has those kube proxy, kubelet, and I'm not going to get into the kube API server anymore, but that is where the instructions get told to where we put our workloads. Then that leads us on to, okay, so what are workloads? Now, you've heard me mention pods quite a few times, and this is the basic building block of our workload. Now, a pod, if we think about containers, a pod contains a container. It can contain more than one. Maybe there's a sidecar. We won't get into that either. Think of a pod as a way of housing a container. And this is the lowest building block of Kubernetes. So we could just spin up a container and we could leverage that. But if you delete that pod, then that pod is gone. There's nothing in place to keep it alive. Great for off-the-cuff type operations. But yeah, generally speaking, you're going to see more, especially when you get into mission-critical applications, you're going to very much see this next step around deployments. And a deployment is, if we think about a deployment as a desired state, this is going to enable us to hold everything in a desired state configuration. So if you say that I want 10 pods to act as my web front end and I want 4 for my backend database, that deployment will keep it in that situ. If you go and delete all of those pods for the front end, it will automatically spin up to get back to that desired state. Now, moving on to one other area, and this is key to our stories around data management, is a stateful set. Very similar to a deployment, but now we have to think about the persistent storage. If you've got a database backend, okay, the front end is important and we want to scale that up accordingly, but we also want to be able to look after our state, our database, our customer information, our important data. Database is exactly the same as what we've known for years, whether it be a database sitting on physical, virtual, in the cloud as PaaS, or rolling your own IaaS type database. And really, this is really what it's going to do. It's going to keep the information about your database or the database itself in a persistent volume, in a LUN that is presented by some either enterprise storage or cloud-based storage. And then how do we access our application? So I've mentioned about a front-end application. I've mentioned about the deployment to keep it in a desired state. But actually, how do we access that from the outside world? And that's where services come in. Now, services can expose various different pods. It could be a web server front end. It could be even a database if you want that to interact to something else. And really, that is a service that bridges that gap. Now, there's a few different ways of being able to get to that, either via like node ports, load balancers, ingress, for example. Again, we don't want to get into the weeds too much. We're just staying on top of the water so that we're not overwhelming you guys or everyone from a learning journey point of view. But hopefully that was useful to talk about the overview of or the building blocks of Kubernetes. And I think we go to another poll, which it looks very similar to the last one, but I think we're focusing on what does the next 6 months, 12 months look like from a planning point of view? Where are you going, or do you have intentions about going to use Kubernetes? And we'll see if these numbers are the same. That'll be interesting, David.
That's right. Yeah. So just like the similar question, are you using or planning to use containers? Here we're talking about, are you planning to use Kubernetes in your environment? And I would say in the relatively near future. Is that right? We ask about planning, Michael?
Yeah, yeah. I would say 6 months, 12 months type time frame. So that's interesting as well, and again, fully expected. Um, if that winds out the same outcome, be interested for another poll maybe later. Not we're not going to get it done here, but that running in production where we said about containers, does that correlate to if you're running containers? Are you running Kubernetes? Are the same people coming up and saying that here? Which is, I think, what we're definitely seeing is if you're there's not many people just running vanilla containers in production. They're generally running it as part of an orchestration engine.
That's right. Yeah. You need that orchestration to ensure the containers keep running.
Yeah, exactly. Going back to the analogy around, yeah, you could absolutely do that with an ESXi host and you could run all your virtual machines, but you probably want to get into some sort of orchestration to look after that.
Absolutely. So let me share the
Cool.
results of this. And it looks like 64% said still learning about Kubernetes. 11% said running in production. I think that was relatively close to the number that were running containers in production as well. What do you think, Michael?
Yeah, yeah. And kind of expected again, right? There's similar numbers to what we see across the board. Obviously, when we're speaking to customers, they're generally running in production, testing. They're at that phase, but I think the wider audience is this is a good overview of what the world looks like at the moment.
Absolutely. Yeah. So just like virtualization, where it's not an island, you need an ecosystem of tools around it to monitor it and protect the data. So Kubernetes and containers are the same thing. So now you're going to tell us a little bit about what we can do to protect the data that's running in our containers on Kubernetes. Is that right?
Yeah, absolutely. So obviously, data's data, right? If you're running databases or data services within your Kubernetes cluster, then you're going to need some way of protecting that. Now, you could try and use an existing technology, and I work for Veeam. Like you could potentially try and use Veeam backup replication for that. But those that are using Veeam out there or any other virtualization based backup tool, you know that it's fit for purpose for what it does. It's there to protect virtual machines, for unstructured data, for physical machines, for cloud based workloads. It's not the same as this platform. And in a very similar world, and I'll touch on the higher level view shortly, but from a Kasten point of view, Kasten was very much developed with Kubernetes in mind. It lives within the same API. Everything was written for, it was purposely built for Kubernetes. And if we think back to Veeam, Veeam was purposely built for virtualization, VMware in particular to begin with, and then branched out. That whole point of using agents on virtual machines was just a stopgap for those vendors to get something to be able to protect their customers. But we all know that an agent-based approach within virtualization was not the right way, whereas obviously Veeam brought out that agentless approach to be able to do that. Kasten Kasten K10 does a very similar approach to that. So,
Cool.
yeah, let's dive into some of the higher levels of okay, so data management in Kubernetes. What do we need to actually protect? Now, also from a very high level overview, is that there's a lot of people that would state, and I use that word intentionally, they would state that Kubernetes is a stateless platform. It's where we should run our web applications that require no state. Like all of the information that we need is built into the container image, and I just want to scale up, scale down accordingly to the load that requires that. But if we look at surveys that the CNCF do, we can tell that over 50% of users of Kubernetes are actually running levels of stateful workloads, whether that be databases, NoSQL, SQL databases, whether that be batch processing, messaging queues, and and just log tracking software that requires some level of state that you want to keep. But then also think about complex applications as well. Yeah, okay, we've got everything in code. That's great. And we're potentially using a CI/CD pipeline. Again, that's great. We have customers that have over 300 namespaces in one cluster, and they're named very similar. Do I really want to be going through and understanding what that looks like, or do I just want to restore my complex stateless application using a tool that knows and breathes the same language? So obviously, stateful is the number one conversation around data management. How do we protect stateful workloads such as databases, except as an example? But then also, how do we protect the other part of that? How do we protect all the artifacts that make up these microservices and containers and the pods, and make sure that they come up accordingly? The services that I touched on, how do we make sure that if we're protecting an application, how do we bring over everything that makes that application an application, i.e. the services, i.e. different configuration parts, the persistent volume, the storage? How do we make sure that that's all protected in one? And it's quite easy to coming from a virtualization background, it's quite easy to pretty much turn around and go, well, data management, well, it's the same, but it is a little bit different, because I don't want to, it's going to be cumbersome to use a different tool that is focused on virtualization. Yeah, I can protect my node, use it, especially if that node, let's say that I've got 3 Ubuntu VMs that are my nodes. They're running my Kubernetes cluster. Yeah, I can absolutely use Veeam to protect that. Great stuff. Now, if I come to recover that, I have no idea about what is actually running on those Ubuntu nodes. I can't be consistent when I'm bringing them back. The state of that, who knows what that's going to look like if I'm using a tool like Veeam. Whereas if I'm using something like K10, I've got the insight, I've got the visibility inside of the application to not only make it a little bit more consistent from a platform point of view or an infrastructure point of view, but I've also got the ability to be application consistent as well. So I'm not going to read through all of these, but I think you'll get the gist of where I'm going, is that if you've got data in whatever platform, then you need to protect it in the most efficient way. And that's probably the key takeaway, is that yes, Kubernetes will help you from a high availability point of view. It will help you from a replica point of view. Very much the same as VMware does that with your virtualization today, with your VMs across all of your clusters and your nodes. But they don't protect your data. What happens if that whole cluster was to die? Or what happens if you, not so much the backup and recovery of that, what happens if I want to move it from one cluster to another? How do I help with that application migration? And this kind of goes on to taking the slide, not the last slide, but the slide before, is that where are we seeing that that challenge around data management? So being able to protect persistent storage, not just protect it, because I can have something go and scrape it. Even Robocopy will go and copy everything from some storage. But how do I do it in an application consistent way and understand everything that is going on with that persistent storage? Complex stateless environments, protecting those MongoDB instances, those MySQL, those database services, Kafka, for example, all of those different data services that we see much more in a web scale environment. How do we protect those? I mentioned about services, so things like load balancing, IP, DNS. How do we make sure that if I'm taking it from here and I'm pushing it back to there, or something bad happens here, all of these failure scenarios, I need it to come back the way I need it to come back. So I need the public DNS or the IPs, and I need the load balancing configuration. I need the whole app and the artifacts that go along that make it the whole working application, and being able to bring back that whole configuration there. And I kind of touched on this as well. Backup and recovery is one part, and we have to be living and breathing that same Kubernetes API. But also think about application mobility. Right at the beginning of the session, I touched on about Kubernetes can pretty much run anywhere, and it will run in your public cloud. It can run on your laptop. It can run on a server somewhere. VMware have a huge play around Tanzu at the moment. It can run as a virtual machine. Literally, there are so many different platforms that in itself is just overwhelming to choose the right place to put your Kubernetes cluster. And it might be, and this is the flexibility of Kubernetes, is if you've built an application that runs on Kubernetes, then you want to have the ability to move it from A to B to C, potentially back to A, back to B, and be quite fluent around where it needs to be, whether that's cost, whether it's risk, whether it's just efficient and performance. So another key part, especially around data management, and this is more higher level than just Kasten, is that I want the ability to be able to migrate those workloads or move those workloads from A to B to C and see what they look like. The other use case that I use here is around, well, I want to know what that data, I want to give that data to leverage that data. I want to use that data. I want to give that to my data scientists so they can look at the Kafka data service and glean information out of that, so they don't need to go into the production. And I can do that by using our mobility services to be able to push that into a different cloud, maybe a local cloud to wherever the data science or whatever that team looks like. And then the spoiler alert here is that failure scenarios still occur. It's still sitting on some sort of hardware. So the fire, flood, and blood doesn't go away just because I'm using Kubernetes. We don't have any of these we don't have any of these failure scenarios anymore. That's simply not true. So we have to think about, what does a native disaster recovery plan look like from a Kubernetes point of view? So built into K10 is the ability to actually replicate your application before anything bad's happened to a different location. We can look after the whole scaling up and scaling down of that as part of a hit a button and spin it up, as well as understanding our catalog so that you know that K10 also can be failed over into a different location. So when we talk about data management, I think we touch on back and recovery, and it's always the first and it's the opening conversation that we have about how do you back up data, how do you recover it, how do you recover it fast, the fastest possible. How do we look after application data? How do we recover that in an app consistent state? But I think the mobility, portability of that data is massive. And I think disaster recovery is still a thing. And we have to think about that as well as part of our infrastructure or platform operations angle. So that was kind of high level. And then we get into Kasten K10. And for those that haven't ever seen anything around Kasten K10, there's 4 key drivers really that we focus on, or mantras. One is around dynamic application discovery. So if you've got applications, we want to be able to just show them to you so that you can go and create a policy around protecting those. But then again, that leads me on to policy-driven automation. You can already have policies created that maybe look for labels or tags, namely anything that has a tag MySQL or production. I want to protect it on this SLA and have that protect and have that automated. I would also add in there around, like I'm showing a UI here, and if you come from from an operations perspective, a UI is generally what we live in. We live in a UI versus a command line, or at least code. Now, the DevOps side of things, where you may want to incorporate backups into your CI/CD pipelines, because of K10 being built from a Kubernetes API standpoint, is we can factor all of that into our GitOps pipelines, so that if any code changes before anything gets committed, let's take a snapshot, let's take a backup, and ensure then that we've got a restore point. Now, as well, if you think about the whole, go back to where I was, is that the release and the update cycle within Kubernetes, within containerization, we're now talking multiple times a week, potentially, of updating our version, our application. So every time I do that, rather than waiting until 8 p.m. every night and giving it the whole night to be able to go and take a backup, I need to be much more dynamic, much more policy driven than just letting my backups run every night at 8 p.m. I need to be dynamic, and I need it to be based on some sort of behavior, whether that's a code change as well as a point in time. But whenever I change anything, whenever I change some code that could affect my data, then I want to take a backup. And that's another key area that we're seeing, is being able to do that. So yes, there's a UI, and everything you do in there, there's breadcrumbs all over so that you could incorporate your automation tools and tasks into your pipelines and workflows, so that you don't have to use the UI, because we're using the native Kubernetes API. And then also end-to-end security. We're talking about data. We have to be able to encrypt that data and make it secure, so that no bad actors can get hold of that data. And that includes things like immutability, being able to provide immutability when offloading that into object storage, or whether you're pushing that into S3 compatible, AWS S3, for example, and being able to leverage the native object storage object lock API to ensure that nobody can tamper with that data for a specific amount of time. Now, from an architecture point of view, it goes very much the same as what we see. And this is a visual to what I said earlier about Veeam being made for virtualization, Veeam being made for VMware. K10 was very much made for Kubernetes. 3 areas to focus on. 1 is we're leveraging the Kubernetes API. 2, we've got the ability to leverage infrastructure APIs. So whether that be your virtual, your physical, your cloud infrastructure, your storage, your enterprise storage underneath, being able to leverage that platform and the APIs that come with that, and being agnostic to that. So everything that K10 is just software. We're deploying that within the Kubernetes cluster. We have disaster recovery to offload that to a different cluster as well, and all of that good stuff. And then the final piece to this is around application focus on your databases or your data services to go up a level, to focus on application consistency, because again, that's still a thing when it comes to cloud native workloads. But I think the biggest focus here, and hopefully that's come across quite a bit when we're talking about pods and containers, the biggest focus is around the application, but not just the application, the complete application when it comes to the state of the workload, the services, the secrets, the config maps that build up that whole application piece, and being able to protect everything that gives you the ability to restore everything if you need to, or be granular about recovering that as well. So if I only need the config map, or I only need the pod or the service, that's fine. I can do that. Then another key part of that is around data and the data services that come with that, but also being, and they put freedom of choice here, but I like to use the word agnostic, and that's another big Veeam thing, right? Is that we don't really care. I don't know if I should say it like that, but I don't really care where your Kubernetes infrastructure lives, and that's the beauty of Kubernetes. I don't really mind what storage vendor you're using under the hood. I really don't mind where you want to store your backups, which object storage, whether it's on-prem, whether it's in the public cloud. I don't mind what distribution of Kubernetes you're using, whether it's a public cloud managed service, whether it's Rancher, whether it's VMware Tanzu, or whether it's just upstream Kubernetes. We've got support for all of them. And then also your data services. Now, I've only got a few on here, but the one interesting one that I'll come out with. So Postgres, Mongo, MySQL, Cassandra, etc., all potentially living inside the Kubernetes cluster, taking advantage of everything that we've touched on around that stateful set. But also think about other external data storage services, such as Amazon RDS. So we can have our stateless workload running in Kubernetes, but we can have plugged in to our Kubernetes cluster Amazon RDS, so a Postgres or a MySQL database, Aurora MySQL, etc., and be able to protect that as part of our whole K10 our K10 offering. So being able to manage everything under that one interface. And then just before we get to some questions, I don't know if that actually builds out. I don't think it does. So let's jump over to this. Yeah. So where do we go next? So obviously a lot of us on the call were very much in that learning journey, regardless of where you are in that learning journey. Hopefully that was useful. But where do I go next to learn more, whether it's about Kasten or whether it's about Kubernetes in general. So first and foremost, the one on the left, number one, is a hands-on lab. A hands-on lab that's getting refreshed in a couple of weeks as well. So there's new stuff coming. But really what this is going to give you is access to a Kubernetes cluster in a controlled environment and give you some overview and theory, but also hands-on to understand a bit more about what it looks like, along with some tasks about creating an application, using that application, adding some data to it, removing that data, protecting that data, restoring that data. But I will say it's a playground. So it's a full Kubernetes cluster. If you've not got round to spinning up something on your laptop, then that's fine as well. But ultimately, this will give you the ability to see that. Now, if you're a little bit further down the line and you do have access to a Kubernetes cluster, whether it's something like K3D using your local laptop, then we've got something else that can potentially help there as well. So Kasten K10 has, as much as it is a commercial product, and obviously I'd love for you all to go out and buy it, but my angle is around the learning, about raising the awareness of what we're doing, but also about getting people to give us feedback about what we're doing. And so we have a K10 version that is free for 10 nodes, and it's free forever. So 10 nodes. So think about your 10 ESXi hosts and how many containers in that meg type format you could actually run with that. And then obviously thereafter you go off to a commercial product and you speak to sales and do all of that stuff. But really, if you've got a home lab, or you've got the capability of being able to push Kasten K10 into an environment that has Kubernetes, then you've got access to that K10 free edition. And here's the kicker, is that the K10 free edition, apart from that 10 node limit, has all of the same functionality that you get with the paid for version, other than support. But our best effort support is really good as well. So I think we're going to finish on another poll, and then we'll get to some questions. So David, if you want to.
Absolutely. Yeah, I just brought up a poll for everyone out there that says, what additional information would you like about the Kasten K10 solution? So we appreciate your feedback on that, and we'll leave it up while we take questions from the audience. So if you have a question about this, now's the time to get it in. We did receive a lot of great questions here, Michael. First one I find interesting here. They're asking, really, do you have any advice on when to use a VM and when to use a container?
So a lot of that is going to come down to your knowing what the application is. So just because you're not going to take something off, it's going to come to whether you have an understanding of the platform that you're going to push that to. It's going to come down to what that application is, what your requirements are around that, whether it's off-the-shelf software from a virtualization point of view, an ISO, or whether it's been containerized. I would work with the software vendor at that point to understand what the benefits are of containerization with that. Are they going to stop developing the ISO version? Because that's one thing that I believe is we're going to see a lot of off-the-shelf software, like we did from an ISO point of view, and how it moved from physical disks into software downloads. And I believe that we're now going to see a container image for a lot of that software if we haven't already. I think it comes down to you have to be comfortable about looking after that application and making sure it's fit for purpose.
Absolutely. Yeah. Great advice. I think, we were surprised one day kind of when applications started being distributed as virtual appliances, and you could just deploy it in, as an OVF into your virtual infrastructure. And then I'm sure you're right here. Very soon we'll see containers being used as the distribution. Another good question here. Any recommendations on the best ways to secure containers?
So there's lots of vulnerability scanners out there, some free, open source projects. I think there's two parts to it, and it's a hot area as well, right? And the investors can vouch for that. There's a lot of money in that space with a lot of open source projects that enable you to do scanning of your containers. I think my biggest advice is don't use use validated secure containers from a proper registry first and foremost, but then also look at that prevention plan about using one of those open source software or a commercial product. There's a number, I'm not going to name them, but yeah, we're also working alongside some of them because everything we do is more focused on the remediation, whereas they're focused on the prevention. And then the big gaping hole in the middle is when bad things happen, which no one can stop. But that's why we're here. But yeah, I don't think there's a way to 100% alleviate and stop security in containers, but being cautious and mindful of it. Don't just be there's security issues in containers. Like, be aware of it, and it's the same as VMs, right?
Absolutely, yeah, great point. Another question they're asking: what do you do to protect the data that you back up with Kasten K10?
So we have various different ways of being able to protect, or different locations where we can store our data. One of which is being able to offload that to, in a future version, not too far away, is the ability to put that to a Veeam backup replication repository. And then thereafter, we've got the ability to take advantage of backup copy jobs and moving that to different locations. So the 3-2-1 rule still absolutely applies to Kubernetes. We also our software enables us to take snapshots in the Kubernetes environment that we're in. Some of those snapshots are durable by nature. AWS EBS snapshots, for example, they literally are a copy of the data. So they can be deemed as another copy of that data. And we're if you've got a MySQL database and you protect that to an AWS S3 bucket, there's nothing in the product that would stop you doing that to an Azure blob storage as well. So if you're really worried about certain failure scenarios, then there's no limit on how many times you can copy that data, other than it's going to cost you some money.
Nice, yeah. Another question: can you back up your containers in one location, say one distribution, and restore them somewhere else? Like from, on premises, you have a disaster, you restore them into the public cloud.
Yeah, absolutely. And you can automate it. So one of the big things, if you're going from on premises, say you're going from a K3S cluster, and the storage class, so the storage there is, let's call it on-premises storage, and that's what it's named in Kubernetes, and that's what our application uses. But then we want to get that into AWS, and the storage class there is called GB2. We have something called application transformation, or app transformation, to shrink that down. And that gives us the ability to change that configuration and actually restore that into different storage classes. So big thing that we're seeing at the moment is about migrating away from in-tree provisioners into CSI drivers. And that's probably going a little bit deeper into the weeds, but application migration that I mentioned, or app mobility, is very much a hot topic for our customers at the moment, about being able to move data from A to B, but then also being able to automate that. So yeah, we can automate that process as well. So you've always got a copy in another location, not running, scaled down, but the data is there ready and waiting in a cold or a warm state if you want.
Awesome. All right. Well, it looks like we're running out of time here in our hour. I'm sure we could chat for another hour about this. Yeah. But before we go, I want to point out the resource here that Michael shared. This is an excellent opportunity for anyone out there who wants to get started with this. There's the hands-on lab. I posted the URL to this in the questions pane there. There's the hands-on lab, and then the free forever for 10 nodes. So that could cover a lot of containers right there across 10 nodes of the Kasten K10 data protection for cloud native apps solution. So excellent resource. I encourage everyone to check that out. Also, don't forget about the handouts tab there. There's a number of other resources to download before you go as well. Michael, it's been great having you on. Really appreciate all your education and wisdom on this topic.
Awesome. Thanks for having me, David.
Absolutely, yeah. And thank you to Veeam, of course, and Kasten for supporting the event today. Check out the resources there in the handouts tab. Check out kasten.io/Michael Cade for more information. And I'll leave that up while I announce the winner of our Amazon $300 gift card door prize. This is going out to Mike Kelly from California. Congratulations. And we'll also reach out to our best question prize winner after the event. Thank you to everyone who joined us on the webinar today. I hope you learned a lot and have a great day. We'll see you next time. Bye-bye.